read chapter 5 and viewed the videos that I put online. I also made an announcement on the announcement page of Canvas, and I went ahead and put the review for our next exam, which is a week from today, so that you can be answering those questions as you read through. Yeah. So did everybody see that? Because that'll help you in case you didn't figure it out from the last exam. So, and then probably, don't count on me giving you extra chances to take the exam every time, because I really don't like having to grade things more than once. But if you do the reviews, like, you shouldn't have any problems. Plus, we always have the extra credit where you can draw details, structure or architectural or structural details, and a lot of those are in the book. A detail is a blow up of how something goes together. Basically, it's a cut through something, like a wall or a foundation. It's not a photograph. It's something that tells you how to put something together. So you draw me details like that to scale and labeled, and then you can add 5 points per detail to any grade that you want. So, okay, on to chapter 5. I'm just going to find there it is. I'm going to look through the PowerPoint real quick just to highlight anything I think you should definitely understand. They talked about balloon framing, which isn't really used a lot anymore. That's kind of an old-fashioned type of construction. We use platform framing more nowadays, so I won't spend a lot of time on that. But there's a good representation of platform framing, which I will spend time on. Basically, you have your foundation, which is your first platform. You build the walls around that. Then you add your second platform, which would be the second floor. Build the walls on that, and you just keep going up and up. And then, so it's called, you build on your platforms. Usually, wood frame construction doesn't go higher than 5 floors because it's just not feasible. It wouldn't be strong enough and stiff enough. So you have to get into steel after that. And it goes through, y'all should have already looked at all this on how it's done. Second, just like I just said, you build on top of each platform. So I'm not going to spend a lot of time there. I just wanted to make any questions on that concept? No? Okay. It talks about foundations again and what kind of foundation would support that kind of structure. This is a picture of a detail you could draw. You can copy things from the PDFs or the slideshows or the books, or you can look it up online. There's some more details of how you might insulate a foundation. That's particularly important in colder climates because you don't want the freezing to make your building heave or get moisture in there, etc. There's just some photos. There's a stepped foundation on a sloped site, and you can see the insulation on the outside. That's rigid foam insulation. Then they get into the platform frame, and they lay out, I think this is in the book as well, they point out the different details that they'll show you. Like, for instance, in case you don't understand that says A, edge detail at the end walls. If you go back to the other slide, that's the detail if they cut it through right there at number A. So that's how that's labeled. Then you've got B, C, and D, so you can look through those. And you'll need this in a little while when we do this exercise. I think this is information you should have gained. They talk about the preservative wood on the sill plate. That piece of wood always has to be preservative treated because, of course, that's where the bugs come in, and they don't want them to get through the bugs, or the bugs to get through the wood. Then they go on up to floor framing. Talking about that, there's a picture of that on top of the foundation. Ground floor walls, and again, you can see the, I'm just going through this fast because then y'all are going to do some exercises to get yourself more familiar with this. Again, you can see detail A, C, F, D, and then you can see where those occur on this page. So you can study those on your own time. This is like an elevation of a wall and how it might be framed. The dashed lines are the studs behind, and you can see the door and the window openings. And they're talking about detail A and B is cut through those walls. There's more studs. You can see it's important on doors. You'll have like a double stud. There's your header. That stiffens the door frame so that when you open and close the door, the wall doesn't shake. Same thing around the window. You have, usually a double or triple stud on the outside, and then you've got your header, which supports the load coming down and makes it distribute down. At corners, you'll usually have 2 or 3 studs bunched together to stiffen up the corner, or where a wall comes in and meets that wall. Then you've got some diagonal bracing that helps. In some climates, in some places, you don't need shear panels, which is what we use here. Which is, if you look at houses being built, you can see plywood or OSB panels all over the outside. We have that here for shear strength because of windstorm. Windstorm is from hurricanes, and you need to really lock your structure together from the foundation to the roof, and with straps and panels and blah blah blah. But up where you maybe don't have wind and that kind of problem, you can probably just have this diagonal bracing instead of all the shear panels on your wall. But we don't have that here. So remember, a few slides ago I showed you how it cut down through A and B. I'll show you that again right there. Those pictures are looking down through A and down through B. So go back to that. There's A at the corner and how they bunched up the studs, and there's B, how they stiffened it where that wall hits that wall. Those are different ways to do that. You'll want to have these nailing surfaces at your corners because remember, you're going to put some sheetrock or gypsum wall board on the inside, and on the outside you're going to be nailing a finish. And you need to have some place to nail the edge to, so that's why that's like that, and it's called the nailing surfaces. It also strengthens up the corner. There's a window, how you might frame out a window. You got the rough sill, the rough opening. When you draw windows on your plans, you always call out the rough opening and the rough height, because that's how the framer knows how big to make it. Then, you wouldn't call out the exact opening size of the window pane itself, because then they would have to figure out how much of that other stuff on the outside to add on. So it's easier for them to frame if you have a rough opening and the rough height. And that's where the wood is. There's a picture of them framing, and then they're going to stand that wall up after they get it all put together. And until they get the next floor and the roof on, they have to have all of the support so those walls won't fall down. So that's what that is, temporary bracing. There you can see the window in the frame. There's a garage. You can see the large glulam header on top, because that's a very, very big opening. You need to have something that will take whatever load's coming down on that and distribute over to the sides, and then down to the foundation. There's the straps I was talking about earlier. Here on the coast, we have these practically on every stud. I think we do have them on every stud. You'll see, we'll hopefully have a field trip next month to a house, and you'll see all this strapping and how much work goes into that. They use that also in earthquake zones. There's a shear wall. You can see they have tons and tons of nails. The engineer will call out how many nails have to be in there to make sure it doesn't fly off. And then they come out and inspect it before you cover it up. Here they're showing the second floor framing. more details from that. You can study that, or you should have already studied it. Then the walls go up again, and there's some temporary bracing. You can see some glulam beams and I-joist in this picture. The beams will carry a load over a larger space where you don't want to interrupt the space with a wall or a column. That's when you use these large glulams. There's a picture looking at it from below. You can see the I-joist here, and there's the glulams. And then after that, finally, you get your roof. There's some roof details or sections talking about the rise and the run. The rise is how far you go up in 12 inches. So like when you have a roof pitch of 4 and 12, 4 is the rise and 12 inches is the run. So you go up 4 inches and over 12 inches, and that's how you get your angle. This one's showing a 10 and 12. He's going up 10 inches and over 12 inches. So the roof framer knows how to do this, really fast. They're used to figuring this out and getting it just right. There's a picture of roof framing with the rafters, and then you've got some dormers sticking out. There's looking from the inside. Dormers are treated just like windows, except in the roof. You can see that there's more support at the edges, and then it'll go out. But you still have to. This load's coming down. It's got to hit this and be redirected over to there. Another picture. There's a corner. How they frame out the corners of a roof. There's some roof trusses. Trusses are a good, quick, easy way to get a roof up fast. The only problem with trusses in residential construction is it doesn't give you any attic space because you have all of this stuff going back and forth in the truss. So you can't really store your Christmas decorations up in the attic or get up there with your air conditioner and vents. It's very hard to deal with. So trusses are typically used more in, I think, commercial work than residential work, just because people want the attic space. Although sometimes it is used, but it depends on the client. Here, this house is fully sheathed and framed, ready for the finished carpentry. And those were the videos. So that's just a quick blow through the slideshow. And then I wanted to show you, I don't know if you saw it because I did it yesterday, but this I put on the announcement page. This is out of a book called Graphic Standards. I don't know if any of y'all are familiar with that, but architects use it quite a bit. It's like the encyclopedia of how to build things. There's probably one in the library, or we might have one in one of these classrooms. But this is the wood framing section, and this is just more pictures of what we studied in the chapter. But you can see they've called out the different terms for these items, and this is just for your reference. I thought it was good information. You've got some details over here on platform framing. What the different things are called. You got a cripple, you got double headers. I'm not going to read through all of that, but it's just good information for how platform framing works. Here's some framing details for openings on the next page. And these are isometric drawings, meaning they're drawn sort of in 3D, but to scale. You can draw these for your details if you want. It's easier to draw straight-on views, which are shown further down. But here's how you might frame some stairs. Shows you that. Here's some roof framing details on different types of roof. A gable roof is just two slopes. A gambrel roof right here has a very steep slope and then a shallow slope. That provides like a good attic room type place. A hip roof has four different slopes at least. They all meet together in a hip. Mansard roof, and it's got a shed roof, which is just one slope. flat roof. Obviously, it's pretty flat, although there's no such thing as a truly flat roof. It's always got to have some slope to it. Gable roof with overhang, gable roof, hip gable, has a little bitty slope on one end. Intersecting roof, dormers, shed dormer, and bay windows. That's how all those things would be framed. Here's some more framing details, where the roof meets the walls. And this, again, this is on Canvas and the announcements. Here's some joist and framing details for joist and sills. And here's some, what I was talking about, like straight on details. These are easier for you to draw if you're not a very good draftsman yet. But this is showing different types of situations that you could draw, corner situations, walls, stuff like that. These are just special conditions, how you might frame those. Eaves and overhangs, that's where you know your roof hangs out over your wall, how those might be framed. Sheathing, like we were talking about for windstorm or earthquakes. And I mean, this is more information than you'll need in this class, but it's just good reference. So I wanted to make sure you saw that. Any other questions on in general on the chapter 5? When do we finish?
We're supposed to read that before next class.
Well, next time we're doing 6 and 7, which are kind of short. So you're supposed to read it both before next time. And then next Monday we'll have a test over 4 through 7, I believe it is.
Next week?
Yeah, a week from today. Ready? Okay. But if you do the review sheet I gave you, you can answer all those questions and you should have no problem. And the review sheet's under announcements. Okay, so now, did I see Thomas today? Thomas Jimenez?
Yeah.
So I can get this back to you. Now we're going to do some framing worksheets. Everyone sign in that's here? Hand these out. How many people do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Instead of me just doing the work for you this time, which I know you enjoy, I don't know that you get much out of it when we do it that way. We're going to divide into groups. Treat this more like a lab time, and you're going to do some of these together. Of course, I'll be here to answer any of your questions. So let's, just reading through, we're looking at the front page, laying out floor framing for exercise 5.1. It says, review figures 5.17 through 5.20 in pages 175 through pages 184 in your text. Let me open that up. That's probably where you're going to get a lot of your information to finish this exercise. 176, they have a framing plan, a floor framing plan, which is basically looking down on the floor and then drawing all the structural joist and in rim joist, etc. on your plan. So it says from these pages you'll need to find the maximum spans for a 2x8, a 2x10, and a 2x12. And then you're going to examine the floor plan, searching for simple arrangement of joists and beams, working the span limits noted above. So you need to know how far those can span. To avoid complications for the carpenters, use one size of joist throughout. So you don't want to have, thinking you're going to be economical, do a 2x8 over here and a 2x12 over there, because then they'll just get confused and put the 2x12 where the 2x8 is supposed to be. So you probably want to use the biggest size all over that you'll need. Draw in beams and locate the post. Assuming the beams can span 15 to 20 feet between the supports, add double headers and trimmers around the stairs, chimneys, and other floor openings. Add double joists wherever partitions run parallel to the framing below. Meaning, if you look at the picture, like if you're over a wall, you'll probably have a double joist versus just a single one, because you need some extra support. Then you lay out the framing for any cantilevered bays. The length of the cantilever should be no more than 1/3 the length of the interior span. So you can't hang out over the wall more than 1/3 of however far that joist can span. Complete the framing plan by adding the remainder of the joist at a spacing of 16 inches on center. That's a typical spacing for a joist. Start at one edge and work across the platform, faithfully maintaining the spacing regardless of the placement of the framing members. Add joist hangers wherever joists are supported by headers. Add solid blocking wherever joists span across a beam or cantilever over a wall. Consider adding bridging at the midpoints of longer spans. You can see all of this in this picture on page 176, etc. You may also complete this assignment using I-joist, and it gives you the... So if you turn that page over, you can see this. Here they've given you the layout for the what they want you to lay out. If you look at the scale, it's 1/8 inch equals 1 inch, or 1 square equals 2 feet. So I have a couple of scales up here if you want to be so exact. You can eyeball it. But what I'm thinking is I want you to divide into some groups of 2 or 3, and then work on this together for maybe 20 minutes, and then we'll talk about what each of you came up with. Is that okay? So, do you want me to divide you up, or can you find your own friends? Y'all find your own friends? Basically, you're going to use that information, and you're going to find the, how far those 2x8s, 10s, and 12s can span, or you decide where you want what. It's going to look like that when you're done, except it'll be that plan. Your first step is to figure out, find the information on wherever page it is. Page 184, 185 to 184, where it says the maximum spans for 2x8, 2x10, or 2x12. Then you can figure out where you want those and start laying it out. You're engineers now, come on.